Good morning. I'm very happy to be here because really I just noticed how much I want to better understand decision making, and especially decision making with, about, and by machines. And to tell you why that is, I think it's helpful to look into my childhood. So when I was about 8, our neighbors were moving. And it was time to say goodbye. But I was playing along in the backyard, and so my mother yelled down to me and asked, "Nina, don't you want to say goodbye to the neighbors?" And I was like, "No, we're playing here." And then she said, "Yeah, they will be gone. And you might not have the time to say goodbye to them. You might not see them again, and you might regret it." And my 8-year-old self thought, okay, regret. So I need to make a decision now that I will not regret. How will I do that? And so this is the how to not regret a decision in the version of an 8-year-old. Collect all available data, neighbors moving away. Collect all possible decisions, saying goodbye or don't saying goodbye. Think through possible consequences. I can play now, or I have to get up and say goodbye to them. And then make an informed decision, deal with the consequences without regret. And that was my plan. And I did not say goodbye to the neighbors, and I never regretted it. So, of course, when you get older, you see that the 8-year-old version does not work, right? So what you see is, most of the time, you can only grab the easily available data, and you have to collect the most important possible decisions, and then the rest you just hope that everything will go on. So given how many decisions we all need to make each and every single day, wouldn't it be nice if we could get some help by machines? And so for that, we first need to talk about what actually is a decision. And as a computer scientist, that's very easy to answer. Of course, a decision is a number, right? So whatever it is, choosing your next car, finding out how many children you want to have, you can always put it into a number, or if you really can't, I would not be interested in it because I'm a computer scientist. And the nice thing about numbers is they can be computed, right? So the question is, can a computer make a decision or at least help you with it? And we've been talking about algorithmic decision-making with the help of AI or just pure data science for a very long time. And in my last book, I tried to find an easy categorization on what kind of decisions we actually make. And I think there's only 4 scenarios of interest. So the first one is we need to make factual decisions, right? The second one is we would like to have a risk prediction. And both of these are facts. In the first one, experts agree. There's a verification process. It's intersubjective. You should come to the same conclusion as I do. And then we can also check it with respect to the quality of decision making. With risk predictions, that's kind of a fact in the future. We can check it in the future, unless my decision today changes the future. So if I do a risk prediction on creditworthiness and you don't get the credit, then you can show me that you would have paid it back. So some of these decisions will change the future. So this is why I've differentiated these 2 cases. Then the most interesting decision-making scenario is judgment. So what is a judgmental decision? I like this definition very much by Kahneman, Siboni, and Sunstein in their book Noise. It's a thing where experts can disagree, but not arbitrarily much. So for example, a grade in university is something where I can give, I don't know, a 1-, and my colleagues give a 3+. We don't have to agree, but we shouldn't be apart too much. So this is judgment scenarios. And then we have singular decisions. And this is what happened in the pandemics. because luckily this was a singular event. This is what happens all the time in globalization. We've not been there before. So this is a part in which we don't have historical databases, and that means you can't get any help from AI there, because if we don't have data, AI won't be able to help you. So now the question is, can the AI make factual decisions? And these are questions that I get all the time in interviews. And the very first thing I say is, we shouldn't talk about the AI. It's a zoo of systems, and it doesn't make any sense. There is no consciousness. It's not one thing. So please be a little bit more specific. Yeah, so that's the wrong question. And then I found a very interesting question in a forum where a person asked this: can ChatGPT help me set prices automatically for products in my store? Okay, that's an interesting question, because we have a specific AI system and we have a specific question. But let's start a little bit more simple. So in order for ChatGPT giving you prices, maybe ChatGPT should be able to multiply numbers, right? So let's check whether AI or ChatGPT in that regard can do long multiplication. This is one English term I had to look up. It's schriftliche Multiplikation. So can ChatGPT do long multiplication of 13 times 25? And then it first explains to me what it does. First, you multiply 13 by 5, and so on. And then it also gave me like a diagram. And it looks perfectly well. This is ChatGPT 3.5, by the way. So, and then I asked it for the long multiplication of longer numbers. And again, the explanation was pretty okay. The number's correct. Yeah, everything looking fine. But here, you see that it does something strange. Yeah, it doesn't actually do it correctly. So there's something going on. And now, in this forum, I try to make people aware that ChatGPT can't even multiply numbers. Maybe you shouldn't ask it to do the pricing for you in your store. But what I found was really intriguing. I had a lot of discussion because there are two opposing views. And the people in the forum said, yeah, the machine can explain the procedure, so it just made a simple mistake. So it is in principle able to do it. It just needs more examples. But my view as a computer scientist is, and now, if you have a software that gives one wrong result, it's not capable of doing it reliably. So it gave the wrong results, plus if you look at the technology, there's no way in which it could have learned multiplication from just examples. It's not possible. But people didn't want to listen to me. So, of course, we see some results that are correct from examples. That's totally understandable from the technology. But more examples will not help fundamentally. LLMs cannot multiply. And I thought that is so interesting that normal people that do not have my education as a computer scientist have this confusion. But then I thought about it. It's the following confusion. I have a 9-year-old. If he can explain the procedure to me and just makes a mistake, I would still say he can do it, he just needs more practice. As a computer scientist, I have to say, if your code is not running reliably what it ought to do, it's wrong. And so I think we need to teach them. So we need to teach them to have a technology-based assessment, and we need to teach them that if you want to have a reliable system, then one single test failing shows you that there is something going on. So that is my main message to you today, that in contrast to humans, a single failed test is enough to show that a machine is not, in general, able to do the tested task, and in general means not reliably, not in all cases. And the problem here is you'll never know in which cases it is and in which cases it is not. Moreover, an explanation by an LLM does not mean they know how to do it. They just know how to create the text that feels like an explanation because they've seen it so often. So, and this is really an article that I would like to recommend to all of you. It's called Intelligible Texturen. It's in German, I'm sorry, by my colleague Jan-Georg Schneider. And he talks about it. Yeah? LLMs create intelligible textures, which we as humans read as explanations. And I think that's a very helpful term. It's not a text written by someone who's intelligent, but we put the intelligence in. So our poor little chappie here cannot do multiplication. Yeah? So even Midjourney cannot write multiplication. So judgments, I think, cannot be done. Let's have, factual decisions have now the advantage that at least we can check for it, right? So a multiplication is a factual decision. We could check it, and then we can decide whether we want to use AI or any kind of software for it or not. So if you want to do a factual decision, you can at least check whether a software is able to do it or not. And as I said previously, with the risk predictions, unless your decision now changes the future, you can check it in the future. And so these are two good categories of decision-making where you can try to use software. So, but now we'll come back to the more complex question the person asked. Can ChatGPT help me set prices automatically for products in my store? And all of you computer scientists in the room know what the person asked for. It's called dynamic pricing, right? So this user reinvented dynamic pricing. And that is so interesting because it means that LLMs create accessibility to coding to a lot of people who have no idea about coding. So when I looked it up on Google Scholar, there are so many approaches. There's more than 100,000 papers on dynamic pricing with different approaches, right? So how would a machine know which of the choices is really the best for you? The best choice will depend on specific conditions. The code must be correct and meaningful. And also, the optimization criterion needs to be given by the user. So we need to do requirements engineering. But the machine will not do that. It will just create some code. So let's come to one parallel that is not often seen. If you now have two of these people that want to have a dynamic pricing, they don't know that it is called dynamic pricing, the machine creates something. And maybe they say something like, I want to be cheaper by 1 cent than the lowest price on this item. That is a fine strategy unless you have two persons that have the same strategy. And this actually happened in Amazon a few years ago when they introduced dynamic pricing. And shortly before Christmas, they had a lot of products sold for only 1 cent until the seller noticed. So this is really a problem, and I think that most of our citizens are not at all aware of this, because the AI is smart, and the AI will give me the best solution. But it will not even ask all of these questions. It will not make them aware of all of these choices they would need to make if they talk to one of us, right? So here we are at the judgmental part, because we now have different things that need to be understood and weighed. So how would we as humans do it? If we do a judgment, we would try to make a model of the situation. How fast do you have your products in the shop? How fast do you need to get them out? We would collect the data. We would do an information selection. Not all of the data is actually interesting. We would determine qualities of each choice. So what are the qualities that we want to preserve? What are the values that we don't need? And then we would consider weighing all of these qualities, make a decision, and then we would be able to justify with our client why we chose this one and not that one. So a prediction of judgment is what the machine does. The machine can predict what the average programmer would choose for a dynamic pricing algorithm. We would give it a selection of a statistical model to do that, to learn that. We would give it data from the past. So this is how dynamic pricing was done in the last 20 years. Then we would give it feature engineering. We would train it on data. It would learn the weight of these features. Yeah, that is somehow similar to the consideration and weighing of qualities. Then the machine would compute a decision and would not be able to justify it. So what is our contribution? That is the human part. We can determine the qualities of each choice individually. We can do it here differently than we would do it there, and the machine can never do that. The weighing would then also be individual. Yes, this introduces subjectivity, but the machine is not objective either because it depends on all of the things that we decided on the right-hand side. And we can give a justification. And yeah, justifications are not perfect. Sometimes we do not know why we actually choose something, but at least we can communicate them in words that are understandable by another person. So my view, and this is only a very small part of the argument why I think that LLMs and other AI systems cannot make judgments in general, so situations in which experts do not need to agree, in which things need to be weighed, qualities need to be weighed. If you want to read the longer one, you'll have to read my book. But the small part is that if you are in a decision scenario in which you have to judge things, machines are not going to help you with the methods we have today. They might be later, but not with statistics. So in general, I think that factual decisions and risk predictions are quite safe. You can try to get help by the machine, and for everything else like creativity. But if you want to make decisions in a singular setting or a judgmental decision, machines are not going to help you. Computer cannot judge for you, so you must judge for yourself. And now we need to give all of our citizens this ability. We need to help them because computer science is much more than coding. But at the moment, it looks as if everybody could just ask an LLM and it will create the code, and that's not true. So here's just a part of the things we do as computer scientists. We are checking hidden assumptions of a computational method. Can you actually use it? Requirements engineering. What is your specific situation? Is that really the best choice for you? We can hopefully give you a mathematical proof of correctness if it is an algorithm, or at least we can do testing for you, and it will be thorough. You might have to look for safety aspects, you might have to look for fairness aspects. So what needs to be done, and I'm happy to have someone from the BMBF here. Tina, I'm looking at you. So what needs to be done? Clear communication about what LLMs can and cannot do, and I think all of us are working on that. Some literacy for citizens, checking solutions, not providing them. They only need literacy. They do not need to be able to code, but they need to be able to read it. So basic computer science and data science literacy, Python coding literacy, because that seems to be the choice of the day. Python is it. Knowledge of quality and fairness measures. Also some basic insights into requirements engineering, because machines might be better if they know more about the situation. So either they need to start asking questions or we need to provide them with more information. And very important, knowledge of testing strategies. And we need to make them aware that they can't judge machines to the standards of a 9-year-old. So that is not the right way. So how to not regret a decision, the AI version, is only use software where it is technically and reliably able to assist you in your decisions. Thank you very much.